Happy Sunday morning, everyone. We want to talk about our coatings this morning. What applications they can be used in, how they're applied, some of their physical properties, things like that. First off, we've got a composite panel here, the gray one. This guy right here. You will see it basically has got more of a satin finish to it. Like it's got almost like a non-skid. So what we did is we took our HTC 70 PA, that is a polyaspartic, and it is 70% solids. So pretty lean material. It's got like 160 centipoise, almost like spraying a resin. All of our coatings can either be brushed, they can be rolled, they can be sprayed. They can be sprayed basically with really any spray component. They can be sprayed with, say, an HVLP gun. They can be sprayed with your cup gun that you'd be spraying Joe coats with. They can be brushed with any brush, right down to a chip roller, or I mean a chip brush. These rollers here is how we were applying this texture. And what we're doing is we're using one of our traction additives in here, and really depending on the coating that you go with is really going to dictate what traction additive you're going to go with. The thicker materials, say it's our HTC 93 or our HTC 100, which is a Tech Pure 0 VOC polyaspartic, or our polyurea. Those are much thicker material, so you're going to be using our larger mesh, so it'll stand proud above the surface. So basically, the thicker material, the bigger the micron that's going to be used, so it'll stand proud. So an example of that, here's even one that's thinner. You can see this is done with one of our aliphatic urethanes, not a polyaspartic coating. So you see we have got lots of different colors, and also it's being applied on wood. So lots of different examples there. This gray one actually comes from this. So you see the glass here. This is a pultruded laminate. It's got a PET foam core, glass on both sides, no coating. They use our coating basically because of that. They have no protection against the elements when you're just running a resin. Plus the aesthetics are not the most pleasing. Here's another example, same exact laminate, but this is with our 93. So it's got a larger traction additive to it. The non-skid is more aggressive. Same exact platform. You can see the texture difference, especially when you're looking at something with that texture. So basically it gives it a satin finish, right up to a pultruded U channel, C channel. Do the same thing. These were all applied with a roller, no brush. This part right here, this was laminated on glass. You've seen this in other videos. This is actually a laminate. We have hit this here with our hammer a total of 8 times. And the 7th time right here, you see it finally gave a blemish. Didn't crack it, didn't do anything like that, but basically what it's doing is it's starting to impact the laminate down here. And following this video, we're going to show you that video, basically how durable this stuff is. The impact resistance that our coatings have, there's nothing on the market that comes close to it. It's like impenetrable. So here's some other fiberglass coatings. This was applied with a chip brush. Cheapest brush that you can apply. You can see it self-levels really, really nice. Another one. So lots of different pigments. So we can pigment pretty much an endless amount of colors. If the volume is there, we can custom pigment, but we've got a lot of colors to choose from. Here's just another little piece that we did. Same thing, this panel, but we use an aqua veil. That's what it's called, our aquamarine veil. It's a water print. And then this one, it's just got a cherry veil on the surface. It's actually this guy right here, coated with a 93 PA with a traction additive to give it that sort of textured print, satin finish. So a couple of other examples here. More Class A look to a really nice satin finish. This was all done with the roller. This guy right here, that's how we applied this. So basically we're pigmenting it, our navy gray coming. And then this guy, basically it's also applied with the 70 PA. Same thing, using the foam roller right here. We're pigmenting it with our navy gray, adding the right amount of mesh in there. And then you've got a really cool surface. Same thing. This stuff just does not scratch. I mean, the impact, the scratch resistance, the oxidization resistance, the UV protection. There's nothing on the market that even comes close to coming to this stuff. Why is it so good on all those fronts? Unlike a lot of your gel coats that are in that 2% elongation, they crack real easy. You get it in your tooling, you get the star cracks, the scratches. When you impact your mold from the back side, moving it around, high-lowing it around, guys that are pulling parts, a lot of times they're using steel to pull those parts, breaker bars, and the edges chip up, they break up, but more importantly, you get those big impact star cracks from the backside. Spraying your molds on the backside, it's because of the elongation property. So this is just left over on the back of cardboard, and you see 400% elongation versus 2%. So we basically can range from a 20% elongation up to a 400% elongation, depending on the coating, depending on the solvent loading, all the way to where we can go and do what the conventional flake, also on wood here, but it can go on concrete, it can go on fiberglass, it can go on wood. These are just some of the examples. Color-wise, we've got a lot of different flake to use. So this could go on top of fiberglass the same way it would go on the wood, can go on concrete the same way. We're going to go ahead and follow this up with our hammer test. We're going to come back and we're going to smack a couple of these guys just to show you the durability with our coatings. Here's another example here. Let me pause you real quick. All right, so this is just a little prototype we made of a pool. So it's all pultruded profile, even got the little stakes. That is a all polyaspartic with micas in it tile. That is one of our veils, all coated with the polyaspartic. Here is a water print, and then here's a really cool one that we did. That's also a veil. Turned out really cool. This is all coated in polyaspartic. Okay, now we're going to go and we are going to do the demonstration video here where we are going to start to smash some fiberglass and polyaspartic. So stick around. Just give me a second. All right, so this guy right here has got 20 mils of coating on and probably 30 mils of laminate. It's got 2 layers of chop strand on the back. You can see where we have just been smacking. That's 7 times in this area and once here where you can see the impact. We're going to do the same thing. We're going to do it to this guy down here. This was going to be a better representation of somebody that is going to spray this on the back of a mold. just to protect against impact, wear and tear from the surface. So this has already been hit once right here. I'm going to try to hit it in the same spot. I'm going to hit it twice. So let me raise this up just so you can see how hard I'm hitting this. This is a 2.5 pound hammer. There's one. You can see where I hit it. Other than smearing the coating, you see how well it does protecting the glass. That could actually be buffed out. Pretty tough stuff.